All right, so I did not have my microphone on. Let's try that again. So I'm gonna let you guys do these problems in a minute. I'm gonna talk through some stuff first. So these are just some general synthetic concepts you guys are gonna see for this chapter. Taking a look at these two problems here, they are very similar looking. The difference being that this has an extra carbon to it. That's gonna change what you guys are doing a lot. So for making an amine here, we want to start with either an amide or a nitrile. We're not adding any carbons, so we need to make a carboxylic acid on this position here. So if I take NaOH, I can make an alcohol. If I oxidize it with Na2Cr2O7 H2SO4, we can get a carboxylic acid. It's probably gonna be easier to go through an amide. So SOCl2, which is a reagent we're going to use a lot today, followed by an amine, NH3, ammonia. And then finally, we want to reduce this down so we can add an LAH. So that was a lot of steps. We had to convert it to an alcohol, oxidize it, make it into an amide, and reduce it. For adding carbon, it's actually a lot easier. So we could throw in Cn minus. We've got the entire scaffold we need. And then we could just throw in LAH. 1, 2 with water. Another option is, it could be a lot more steps. You can add an Mg. I'm gonna write this down just because you guys are gonna use it a lot for other things. So if you throw an Mg, followed by CO2, followed by water, you can make the carboxylic acid version of this. And then from here, we're just plugging this into what we're doing over there, SOCl2, ammonia, LAH, and you can get your final product that way. Some reactions you're gonna have to actually use CO2 because you're not gonna want a nitrile, although there are ways around it. So we'll talk about those a little bit once we start getting going. But I wanted to give you guys kind of a crash course on things to look for when you're doing these. A lot of them are going to revolve around how many carbons do you have, how do you break them, how do you add them. So I'm going to throw up the problems to start the class off with. We'll give you guys about 10 minutes to go through those. And then we'll do some more synthesis problems. And that'll be it for today. All right, so I'm gonna give you guys about 10 minutes to go through these. A couple of steps may be optional depending on which pathway you choose to go through. You can shorten these down a little bit, but this is just kind of a general number of boxes that you're gonna need. All right, let's take a look at this first one. We've got an isopropyl with a bromine here. I track that onto our final product. Our carbonyl is 1 carbon over. We're probably gonna need to add in an extra carbon here. So 2 different ways we can do this. They both got the same product. I can either add in Mg followed by CO2 followed by water. You could also add in KCN followed by H3O plus and heat. Both of those get you to the same thing. From here, there are 2 different options for how you can do this part. You could either, let's take what we have. So we have the carboxylic acid already. If I throw in what, SOCl2, I can make an acid chloride. And then throwing in our carboxylic acid can get us to our final product. You could also, instead of doing this, you could throw in just an acid chloride version of your carboxylic acid. It'll do the same thing. So you could do it in one step also. So either turning this into the acid chloride or just adding in straight acid chloride. Either one of them will be fine. Oh, nope, I deleted a carbon here. Now let's take a look at the next one. So kind of got the opposite. We don't need to add a bromine for this one, or don't need to add any carbons for this one. And the reason for that, so taking a look at what we're starting with. Versus our final product, we have the right number of carbons. So if I try to throw in either Mg, CO2, and water, I'm going to end up with an extra carbon more than I want. Same thing if I do the CN minus H0 plus and heat. Both of these end up giving me an extra carbon more. I have 2 carbons off the benzene ring. I found a product here, I only have 1, so we don't need to go through that pathway. That's not going to get us anywhere. Instead, throwing in NaOH. Oh, I keep drawing these as aromatic. I gotta stop doing that. It's just kind of a reflex to put those in when I draw a cyclohexene now. Gets us to an alcohol. We could oxidize this with chromic acid, Na2, Cr2O7, H2SO4. water. And then to make an amine, SOCl2 and ammonia. Did I skip one? I feel like I skipped one. No, okay, I got it down. All right, I've got benzo. Oh, question in the chat. No, so someone asked if I need pyridine when I'm doing this reaction here with ammonia. Because this is a base, you don't need to add in a second base. If you're doing like an alcohol or something like that, you would need a pyridine there, but you don't for amines because amines already are bases. Okay, so for this one here, I'm going to go back to an old reaction I like to use a lot, which is if I oxidize this, I can just take this benzoic acid, which will be a lot easier to deal with. So adding in Na2Cr2O7H2SO4. Gets me to benzoic acid here. From this point, if I want to reduce this to an aldehyde, I could do this two different ways. I could either just throw in LAH and PCC. The other option, SOCl2, followed by I'm blanking on this. I'm making aldehyde. Okay, LiAlOR3H in water. All right, last one, which I think was probably the most straightforward one. Yeah, okay. All right. All right, let's make a carboxylic acid. So that's what we're doing for this chapter. So Na2Cr2O7, H2SO4, and water. From here, we want to do a carbon addition. We don't really want to overly reduce, so we could throw in SOCl2. Do our light alkylation with lithium, copper, and then in this case, we're adding 2 carbons, so ethyl. Technically, you could also do this through like PCC, Grignard, PCC, same concept. A lot of these reactions at this point, you guys are going to know multiple ways to do them. So there's going to be some options. There was a reaction that I apparently missed when we were talking about things, so I'm going to go over it now. And that's just a way to make another way to make an amine. So this was, it's kind of a chapter 19 concept. Let's do, I'm going to draw an example. I'm going to use a synthesis to kind of teach it. Let's do this. Okay, so we know how to make amines through either amides or nitriles. The other way you can make one, especially if you want one that's substituted, to make an imine, it's kind of an obvious reaction if we think about it, but throwing an LAH with an imine here will reduce this, just like it would for a carbonyl. So that's another way for us to make amines. So we can throw that into one of these reactions here. If I wanted to make this compound, I got to add some carbons. I probably want to make an imine and reduce it. So let's add SOCl2. We can add the ethyl. So LiCuEt2. We can make an imine. So we're just doing what we did down here. H plus NH2. LAH. And water gets us to our final product. So this is another reaction to kind of put in your guys' tool belt. I think it's pretty intuitive based on everything we've already done. We're just producing something different with LAH instead of what we typically do. So I'm going to give you guys 3 synthesis problems to go through. We'll see how far we actually get on them. There was a tornado drill in the first class, which kind of threw us back a little bit. So I think we only got through the first 2 questions. So we'll probably do the same for this one. But let me write down these and then give you guys about 10 minutes to go through them. Cool, so take about 10 minutes to go through these. I might give you some hints in about 5 minutes if you guys are getting stuck. So I will see you guys in a few. I wrote in some hints for the first step of all these. All right, so I realized I had an extra carbon here in the morning class, which is why this is a little bit more forced, but the way I currently have it written, you can do it two different ways. Oops, did I not have that? No, I just draw them in, okay. So I did it this way in the morning class, which would have required you to do what I'm gonna do. But I'll walk through it for what you guys had. You could either reduce it, eliminate it, and then oxidize it, but also you could just throw in chromic acid. So Na2Cr2O7 H2SO4. Let's just oxidize this last position all the way to the carboxylic acid. From here, we want to add in 2 carbons. We can throw in SOCl2. We could either reduce to the ketone or do the alkylation now. Let's do the alkylation now. So if I add LiCu methyl, reduce it, LAH, and then I can alkylate. So that's one way to do this. There are other ways you can go through this. Like I said, I should have put a little more thought into it to make sure I didn't do that, but oh well. All right, so next one looks like we're going to be using an imine. Two different ways we could do this. First step, so taking a look at it, got this like isopropyl group. It looks like we need an extra carbon for where our carbonyl is going to be. So if we throw in either Mg CO2 and water, we can add that extra carbon. You could also do this with KCN H3O plus. From here, we need an extra 2 carbons on the end here. So let's throw in SOCl2. Do our light alkylation. So LiCu, we want an ethyl group. We want to make an amine. So we can go through an imine to do this. So throw in H plus, H2, this is ethylamine. And then I can reduce this with LAH to get to my final product. All right, I'm gonna stop here. We got a fire or a tornado drill in the morning class, so we didn't get all the way through this. The last problem, even though we have a little bit of time right now. So we'll do that on Friday, and then we'll do some NMRs and maybe start on chapter 21. We'll see if we get there or not. So I will see you guys on Friday.